Hi everyone, in this video we will cover several types of discontinuities. So when we talk about discontinuities, there are like sort of 5 types of discontinuities that you can consider. The first one is discontinuity at a point, or what we will call removable discontinuity. The next type is pretty similar to point discontinuity, which is jump discontinuity. Then the third one, we have endpoint discontinuity, which happens when our x is at the boundary of our domain. The fourth type will be infinite discontinuity, and the last one will be oscillating discontinuity. So in this video, we will only cover the first 3 types of discontinuities, and the rest will be covered in the next lesson. So before we go to discontinuity, we need to know what are the definitions that is used to fulfill the conditions for a function to be continuous. So the first one, the function values at x equal to c exist, or similarly we call this fc. The second condition is the limit as x approaches particular point, let's say c here, is exists as well. So there are 2 things that we need to prove. The first one is limit from the left, and the second one is limit from the right. The third condition that have to be fulfilled is that the function value must be equal to limit of the function as x approaches c. So we move to the first type of discontinuity, which is removable or point discontinuity. So intuitively, you can see this from a graph. If a function is a straight line like this, let's say here is c, we say that it is continuous. But if there is a hollow point within the line, let's say here at x equal to c, so we say that this is removable discontinuity. The second type of removable discontinuity is that we have values defined everywhere, but still we have a hollow there, but it is filled somewhere else, which means at this particular point x equal to c, the function values is not on the line. Okay. The second type of discontinuity is jump discontinuity, which is pretty similar to the first one, to the point discontinuity. The difference is that instead of jumping at only one single point here, the whole portion of the graph jumps. Let's say we have a graph here, and then the graph jumps to somewhere else. Or it can also be like this, or this. Okay, you can have the point filled first, and then it jumps somewhere else and become a hollow point. The third type of discontinuity that we want to cover in this video is endpoint discontinuity, which is, I believe, very familiar to most of you. So basically, when we have a domain, let's say a and b, so we say that the function is continuous everywhere between a and b, but at a and b, the point is discontinuous. This is due to the fact that limit from certain direction is not defined at A and B as x approaches A and B. Okay, let's take a look at one example. Let's say we have fx defined by square root 4 minus x squared. We can try to find the domain. It's 4 minus x squared greater than or equal to 0. Then we have 4 greater than x squared, which means x is between 2 and negative 2. If we plot the graph, it has something like this. This is 2 and then this is negative 2. We say that the function is continuous everywhere except at the point x equal to negative 2 and x equal to 2. And again, this is because of the limit. For example, when we check the limit at x equal to negative 2, from the right, the limit exists and equal to 0. But if we check the limit from the left, here, the function does not exist. So, it means that the limit as well does not exist. So, because we fail to fulfill the condition for a function to be continuous, the first one is function values. Yes, it is there. And then they check the limit. Unfortunately, the limit from the left does not exist at x equal to negative 2. So it fails the second condition. So we conclude that the function is discontinuous at its endpoints given the domain. I guess that's it for this video. Thank you.